Feels a little bit like a confessional here, so I hope this can be a safe space. A little bit of a trigger warning. Hopefully a friends of yours may have made these mistakes. I know I've made plenty of mistakes in my career. In the transportation industry, when there's mistakes, people talk about them, right? And that's how we prevent making mistakes in the future. So that's what I'm trying to encourage here. Let's talk about things that didn't work out so well. Maybe have a few laughs. Hopefully we can find some humor here. So this is AWS focused because everybody's in AWS. Sorry, Cloudflare, and sorry, Microsoft, but I guess that's the world. So serverless is stateless. Who agrees with this? Oh, only a few? Okay, that's fine. So classic serverless use case. We got a step function, breaking up some PDFs, doing some image manipulation, maybe reading files in from S3, writing them back out to S3. So everything's great, right? This application works wonderfully. I see some smirks. How does this fail? Any suggestions from the audience how this might fail? Oh, yes. TMP is stateful per instance, right? But this is like, if you have the right sized file, and if you have a bursty load, you'll flush temp because you'll be flushing those instances. So after some time, it'll fail, but as soon as it fails, that instance gets flushed, starts another instance, you restart from the state machine, error handling takes care of it. Now, so we clear out TMP, say, okay, that was a stupid one. We can do better next time. We keep running. We now, maybe every 2 weeks, our deployment cadence is starting to decrease on the app. We keep getting errors on this. We start to get out of memory errors. People can't figure out, they go and they turn debugging on, right? Well, what is touching a variable on Lambda it recycles your instance. We had to take a Lambda, we had to put it in isolation, we had to keep the concurrency at 1, and we had to start running images through it until we found that after 12,000, it would hit an out-of-memory error. What was happening? ImageMagick apparently has a 20-year-old bug where it leaves a file descriptor open. And so you would eventually fill up memory and fail memory on the Lambda. So this was made more difficult because of the recycling of environment variables, but that led to the actual solution, which I don't think there's anybody from AWS here. After processing an image, if you just update an environment variable on yourself, you will flush all versions of the Lambda that's running, and you'll just recycle. I see some smirks. I think that there's some people in the audience who have done this. So we've just proved that serverless is stateful. Another use case here. We're in a microservice environment using JWT tokens. Everything's great. You now want to add session invalidation. Put on Passport.js. Everything works great in dev and test, right? How does this fail? Well, as soon as you have a second instance, right? You have a second memory space, boom, right? The solution that I've heard is to try Cognito. I would leave that as an exercise to the user. I've not heard positive responses after somebody goes home and does that on their own. So we got burned by Cognito. It's not a very funny story, so I don't know if it's to be included here. What about S3 is global? Who agrees with S3 is global? Nobody thinks S3 is global. What's that?
Not anymore. The next slide is probably saying no.
No, so it's great. We built in East 1 because everybody else is building in East 1. That's where all the cool kids are. We have our pathing, our S3 paths, and of course, you want to hard code your strings in all your CloudFormation templates and app code and CID, CD scripts and your manual manipulation. So how does this fail? Fall 2019. What happened? I think it was fall in 2019. Global DDoS on the S3 global endpoint. So if you'll notice here, it has S3 versus a regional endpoint. So S3 was still up, the regional endpoints were still up, the regional DNS was still up, everything was still there and accessible, right? All the nines of S3. Just the one thing that was down was the global endpoint. Well, what is the one thing that our whole application and all of its build systems and all of its associated maintenance code relied on the global veneer on top of this multi-regional service. So we couldn't launch new versions of the code. We couldn't build new versions of the code. We would have had to rewrite the deployment scripts for the build system, change how the build system stored things, retrieved them. Oh, again, bonus for the user, if you implement best practices for CI/CD, you only let code get into production if you've merged it through a GitHub PR, so now you have to go and touch more systems. And the controls that were supposed to keep you safe and keep your system stable are now keeping you from actually recovering from an outage, so oops. Okay, S3 has infinite read. Yeah, okay, good, I got one. So use case. Data lake, so we're just writing all our millions and billions and trillions of images and JSON files into S3. We were processing things in batches coming from our clients, and so we keyed it based on day, and then we had a random transaction ID, and then the type was like a data type, like whether it was particular, final version or some debugging internal output or maybe some particular attribute about the package that came in. And so we wanted to add reporting to this, and so we took Athena, serverless reporting tool, and we pointed it at this data lake, and we started to write some reports, render them into QuickSight. Everything's good, right? Works in dev, works in test. You ship it and then go off on your Christmas holiday, right? Yes. Athena and S3 seem to like communicating in 429s. This is what we learned. You have to pay extra to learn this because you have to turn S3 metrics on so that you can then determine that S3 is returning 429s to Athena. Now, Athena has all this retry logic, and it's going to pull as much data from S3 as fast as it can. And so it welcomes the 429s. It just says, like, okay, well, how much data do you have, and how many shards do you have? And that's how it communicates. And S3 at the time, I don't know if there's anybody who knows, they needed a fixed path and then some randomness. So a fixed prefixed and then some randomness, and that's how it would do the sharding internally, right? Because it needs to define which server the data is actually going to go on. So let me just jump back for a second. So if we look at this, we see that we had the day key in there. So that would create a non-fixed path for S3 to shard across. So it was hotspotting. Athena was now hotspotting a single shard and which was exactly the shard we needed for our transactional writes and our transactional reads. Some other great bonuses here. S3 is so reliable that we had no tests in our code to check if S3 failed on a read or failed on a write. We assumed if S3 is not here, like the world has come to an end, and like we'll just restart the transaction at the top, just restart the step function because something terrible has happened and we don't need retries in the code itself. I already talked about definitely do it before you leave for Christmas vacation. That's a good time. Everybody likes, everybody's free anyways and in convenient places. If you use your reports to check on system health, so you can tell, our transactions succeeding or failing, then you can use that and give that to your users, but you can also use it as your operators. And then when there's a problem in the system, the operators can then go to the dashboard and all refresh it as well. So they can all trigger Athena queries onto the same hotspotted, so you can DDoS yourself. You can actually help Athena DDoS yourself. So that was a fun one. So of course, right, like after that, we're gonna turn the reports to scheduled refreshes, and and do some other things. So S3 has replication. I don't know. This is a true statement. That's not a trick question here. Okay, we were hotspotting the production data lake. We should probably replicate it, create a read instance, point our Athena reports at that, and then schedule refreshes. So that was great. Everything was working, right? We start increasing more data. We start adding more graphs, more Athena queries. How does this fail? Well, finance calls. And your data is now in US East 2, or our data is now in US East 2, and our Athena queries are still being run from US East 1. And we are now reading several terabytes a day or more, several terabytes an hour, and transporting, then paying Amazon for the privilege of shipping data from Ohio to Northern Virginia to process in Northern Virginia, and then put up a graph at 1 a.m., and then do it again at 2 a.m., and then 3 a.m., and then. So it's hard, though, to deploy your code if your build system is in East 1 and change it all and set it up to deploy in East 2. And I mean, finance just thought it was getting a little expensive, so if you just turn down the refresh on the reports that you don't need, you may not have to actually move your code. So this might not actually be fixed. I don't know, I left before that was the case. So we'll put a question mark next to that one. So S3 has infinite capacity. Yeah? Yes? No? I think it has infinite capacity to charge you money. That's my general opinion. The lifecycle policy is optional, right? And it's only 2.3 cents per gigabyte month, right? It's nothing, right? You just write another JSON file, write another image, write some interim debugging output. Again, this was the sort of the keying structure. The mandate was, we're not quite sure. When in doubt, write it. We can always clean it up later. We have this day-based pathing, so we can delete things. It's not a problem, right? So this was performant on transactional level for operating. And for doing the Athena queries, we could use that day to do, we could downscope it, and so we were only doing, when we were transferring into Parquet format, we could use the day as a partition key. So it was performant on the, except for the reading across region part. Let's leave that out for a second. We could read just the day that it mattered. So any thoughts on how this might fail? Okay, well, finance calls again. This time, it's a little bit trickier because we're now storing so much data because we've increased the amount we're writing per transaction. We've increased the number of transactions that we're doing. And we're now ready to implement a lifecycle policy. So this keying structure I just talked about being performant, this lifecycle policies need a fixed prefix, and you can put like a star, but it's a star at the end of the lifecycle policy. So if your type of data determines how long you want to store it, if the type is final output, for example, you want to store that for 7 years. We were in a finance industry, so you want to store that for a long time. If the type is some interim image or some interim blob of your OCR or something that's bloated, you just want that for some debugging. You don't mind flushing that after a few months. So this created a problem where we couldn't actually flush the data that we wanted to flush, and we were going to have to keep all the data for 7 years. So helpfully, Amazon suggested that we go and transition all of the files to Glacier, which that would have worked. That would be a really nice solution and really have dropped the price. There's one small little warning that pops up in the console when you go to transition buckets or transition objects to Glacier. I don't know if anybody's seen this. There's a warning that transitional request charges may apply. It's curious. Okay, what charges exactly? And if you calculate, at least on this bucket that we were looking at, our million, billion, trillion, however many objects we had, the rough cost was about $100K to press that button in the console. I don't know. Has anybody pressed a $100K button in the AWS console before? I have not. Oh, the film guy in the back is. Yeah, that, and as you can imagine, not a lot of either operators, SREs, DevOps, like what developer is going to be like, oh no, yeah, I have authority to press that button. So of course that creates this organizational discussion, right? It leads back into now we really need to gather requirements about how long we're keeping this data. Why is it costing us so much? Why is it going to cost us 100K? Oh, by the way, it's only costing us what, 15, 20K a month right now. Like let's have another meeting on it. Let's have another. You find that your team starts to rotate out of your company. And if you do this long enough, you can actually have everybody rotate out. And so then it could still be there. I don't know if they've even implemented the path-based policy to do the 7-year retention on anything. So this one's a little bit frightening. Infrastructure as code is just YAML. Just some config, right? More smirks. Okay, I know that, I guess the cockroach gives it away though, right? No tests needed, right? You're leading the industry. Everything is like, you're doing better than all those other people. Like just go out to happy hour and everything's awesome, right? This got us into trouble in some really interesting ways. Infrastructure as code, when it contains states language and defines step functions, which step functions were great. They saved us from a lot of other problems. And given the transactional or the batch transaction processing we were doing, it was a very good fit for what we were doing and helped us in a lot of ways in visualizing it. And so it was very powerful, but it also bound that infrastructure as code, that YAML file, to the control flow of our code. And I don't know very many organizations that test the error paths, both the known errors and the unknown errors, well. This makes it more difficult. I haven't seen good testing frameworks for how to implement, inject errors into states language inside of infrastructure as code. Maybe there's some out there that I'm not aware of. That's fine. Another embarrassing one. So as we come to the confessional, continue the confessions. We had a VPC that was in infrastructure as code. That was great, and everything's wired up. It's named great, driven off of variables or attributes. If you don't check that the attributes are different on the input to your template, you may deploy a VPC that you think is in multi-regions, but actually has just been defined to have a duplicate of subnets in the same AZ. Does that make sense? The other thing that we found out was that we had an outage. It was luckily not production outage, but we had an outage where the AZ across accounts, the mapping of AZs to physical AZs did not match across our accounts. So it would fail in one account, but it would not fail in another account, even though the variables into the VPC infrastructure as code was the same. And we found out later that they were different per account. We could bind new accounts to be exactly like all our other accounts. I'm not sure if this has been changed at an org level. I'm seeing some nodding or this may be changed. Ask your TAM, I guess, is the takeaway there. Yeah, and it's also, you can find this during a failover test or a DR test. So if you're doing tests of failure, this is probably a good place to do it. So more infrastructure as code fails. Yeah, ELB access logs. If you're not going and checking that they're getting emitted, even if you think you're generating them, they might not be there, I guess is my point, when you get DDoS'd and you're looking for who's sending you a bunch of traffic. This one, I don't know why. Amazon loves their 2 pizza teams. and where it gets incredibly frustrating to me is Lambda very helpfully will create a log group for you. And that log group is named something that Lambda decides on. And it will set the retention policy to be infinity because it doesn't know how long you want to keep the logs. I don't think they know that they want you to keep them for forever, but that's what ends up happening because either you end up creating more and more log groups each time you launch a new stack and you create a new log group that you're going to have to then go into CloudWatch to delete, which now CloudWatch has a selector to select all to go delete log groups. I think this is literally from customers who have created so many log groups with retain infinity that the customers got PO'd and finally CloudWatch decided to add that functionality versus Lambda going and letting you configure which CloudWatch log group to create or to pipe logs to. The other problem is once you've created the Lambda, if it's named, then how are you going to ever pull that log group into infrastructure as code? I've never seen that happen. We've always just ended up changing the name of the Lambda and gone in and cleaned up manually in the back end. Did you have a? It's coming.
Well, no, it's ugly, but there is a workaround for it.
Okay. We'll take a look. We'll take a look.
No, that's 100% of it.
Yeah, and then the tooling that I have seen, I think could best be described as needs improvement. Native runtimes are the best on Lambda. There's laughing. I actually do think the native runtimes are the best because isn't the whole point of Lambda that you don't have to run on, you don't have to build your own OS, you don't have to manage all this complexity, right? Where it does get problematic is the best practice as I've heard of it. Well, how did we run into this problem? We ran into this problem because AWS on Python, and I believe it was Python maybe 3.2 or 3.4, stopped bundling requests as part of their Boto 3 SDK. And so they can go and update the SDK as part of the native runtime. They generally will send you alerts, and if those alerts are not going to the right developers in your organization, they might be helpfully archiving them and leaving them for somebody else to deal with sometime later. So they can change the SDK, and the best practice of even though that the SDK is included as part of the native runtime, AWS suggests you pin the SDK by including it as part of your own code bundle. Well, for Node at least, that's a very svelte 75 meg of SDK, or 30% of your budget for code. The other solution is you then use custom lambdas, which you then get the privilege of paying for, and you get increased cold start times, roughly in the 3 to 5. I don't know if other people have better stats on this, but seeing roughly 200 to 1,000 millisecond slowdowns in container Lambda cold starts versus native runtimes. So kind of painful either way. I still go with the native. Scale on demand. Yes, to infinity and beyond. So we were working in a microservice environment, and we wanted every service to pack its own backpack, which meant that it needed to deploy all the infrastructure it needed. It couldn't rely on some other service to do it. And so to do integration tests, we needed to deploy fleets of CloudFormation for each Git push. So on each PR, we deploy this fleet of CloudFormations. You isolate each developer from each other, each change that they're making from each other. It worked out great. Well, until you hit control plane API limits, and for REST APIs, you can only create 2 custom domains per minute. I think CloudFormation is known for its minutes to dopamine, or maybe hours to dopamine. This was definitely helpful for developers to help them with the XKCD comic of instead of their code compiling, it's launching on CloudFormation. That's why I'm shooting pool or shooting Legos with a Nerf gun or something. It's also great, I would suggest you turn on config, and then you can pay and make sure that they hit their quarterly revenue numbers with all these infrastructure changes you're making, because in your dev environment, you definitely want to see your highest bill going to config when you're running a serverless code. Apparently, I've been talking to our rep that the suggestion or the best practice for how to use config in a dev environment when you have serverless is to turn it off. Still pending, but it seems like an odd suggestion from the rep we've talked to. Okay, how am I doing on time? Serverless is secure. I get a big laugh out in the back. Okay. This one is, luckily this did not make it any further than an architecture review when the serverless architect kind of pulled us aside and said, how you wrote that Lambda permission policy, technically any API gateway inside of AWS could invoke that Lambda, because you're just constraining it to API gateway and Lambda invoke. You didn't actually restrict it to a source ARN of the exact API gateway or to the account that you were in. So, kind of dovetailing, even if you don't have stars in policies, sometimes permissions can be overly broad in ways that might be easy to copy and paste around, but could potentially create real problems. So luckily we found that. Okay, just covered that. So this is me, co-founder of Cyclic. We're a serverless Node.js platform, much in the vein of infrastructure from code. And you can reach me on Twitter, and that's my email. And so would love to hear your stories of fail. I'm sure we all have funny stories that maybe we can only recount in a more private setting, but hopefully I can break through the wall and start a little bit more of a conversation. So thank you for entertaining me.